polynomial equations that are not technically quadratic, but they reduce to being quadratic. So for example here, I have x to the fourth minus 9x squared plus 8 equals 0. This is not a quadratic equation because it leaves off with an x squared to the fourth. We would like it to be x squared. But if you take a really close look at these powers, this 4 can break down to 2 times 2. And this 2 can break down to 2 times 1. And if we put x squared inside of a set of parentheses, raise it to the first power, raise it to the second power, then we're going to turn this leading term into these parentheses squared. Then whatever inside the parentheses, that's going to be the variable u that we're going to use the magic 3-letter word here, let this variable u equal x squared. And then we substitute the u in here and here, and now you can see how this equation reduced down to a quadratic equation. So again, this x squared is always what we're looking to put inside parentheses squared. So here, now we can factor two numbers that multiply to be 8, add up to be a negative 9, minus 8 minus 1. So we're going to solve this for u. Then you bring the x back into the problem. So now you bring this x squared, replace your u's, and now solve for x. Take the square root of both sides. You get the square root of 8, which is 2 times the square root of 2. Remember, that's 4 times 2, and the square root of 4 is 2. Always a plus or minus here. X squared equals 1. Take the square root of 1 as positive or negative 1. There's your 4 answers. Remember, x to the 4th, at most 4 answers. All right, next example. Sometimes they're going to jump right out at you. Come on, mouse. Quit being so sensitive. All right, here we go. Do not distribute the minus 5. Do not write this out twice and FOIL it. Notice that both sets of parentheses are exactly the same. Wait a minute. There's my parentheses squared. Whatever inside the parentheses has to be my u. So u is going to equal the x squared minus 1. Take that out. Put u squared minus 5u plus 6 equals 0. Factor and solve. Two numbers that multiply to be 6 to add up to be a negative 5. How about minus 2 minus 3? Solve for u. Set them equal to 0. U equals 2, u equals 3. Now, here's the nice thing. Is you can solve these simultaneously. Bring the x squared minus 1. Put them back in for the u's. Both cases, add over 1, add over 1. Both cases, got to take the square root. Square root of 3 is plus or minus the square root of 3. Square root of 4 is 2, so positive, negative 2. There's your 4 answers. Okay, what do we got going on? Oh, we don't have any parentheses, but here's my 2, but it's a negative. Here's my 1, but it's a negative. So what we want to do is think about this negative 2. On your x only, not the 2, just the x, that's going to be x squared raised, no, check that, x to the negative 1 inside parentheses raised to the power of 2. So u is my x to the negative 1. So now it's 2u squared plus u minus 15 equals 0. All right, to factor this, we got to use the old technique here. What two numbers multiply to be AC? 2 times negative 15 and add up to be 1. This is the odd rule because b is odd. And remember we said that if b is going to be odd, you need odd factor, an odd factor and an even factor. So break your 15 down. 3 and 5, it's either going to be 3 times 10 or 5 times 6. Which one of those two are going to add or subtract? In this case, subtract because 15 is negative. Subtract to be that positive 1, it's got to be 6 and 5. So 6 will be positive, the 5 will be negative. Take that 2u, write it in twice, both binomials, put in your two numbers, minus 5 plus 6. Because I'm using one extra 2, one of those parentheses, the second one has a GCF of 2. We're going to divide out that extra 2 we put in, and now that's factored. We'll set those equal to 0. Add over the 5, divide by 2, subtract over the 3. Bring in x to the negative 1 for u. Now, to get this negative 1 to be a positive 1, you have to raise it to the negative 1 power. So both sides raised to the negative 1. So negative 1 to the negative 1, that's a multiply the powers. That's going to give me x. 5 halves raised to the negative 1 power, that's your negative exponent rule that says just flip the fraction. X is equal to 2/5. We'll do the same thing over here. We'll treat negative 3 as if it's over 1. Flip it, 1 over negative 3, or you can think of it as negative 1/3. Next, solve for x. We have x to the 2/5 minus x to the 1/5 minus 2 equals 0. Okay, there's my power of 2. That's going to be in the outside the parentheses, so x to the 1/5, that's my u. So that now gives me u squared minus u minus 2 equals 0. This factors to u minus 2, u plus 1, which we then can solve for u. How about u equals 2 and u equals a negative 1? Sound good to me. Then we'll bring back the x to the 1/5 power. Now remember, fractional exponents are like radicals. This is the same as saying the 5th root of x to the 1st power. So to get rid of the 5th root, you take it to the 5th power. So 2 to the 5th is 32. Negative 1 to the 5th is negative 1. Now, you could double check all this crazy work. You can go to y, type in x raised to the power. So here I'm using, again, older screenshots if we got anybody with an older calculator. Your newer calculator, when you hit raised to the power, you get the little text box and you can put in your 2 divided by 5 up there. You don't need the fraction, the parentheses, because it's all in that text box. Minus 1 raised to the power of 1 divided by 5. New calculator, you don't need parentheses. Old calculator, you do. Now, because one of my answers for x is really big, when you graph this, you've got to go to your window first. Usually it's negative 10 to 10. You go change your x max to 40, something bigger than 32. Then you graph it, hit the graph button. Here's your graph. It puts the equation up there. I'm going to hit the trace button. I'm going to type in negative 1, and it gives me a 0. There's the 0. I type in 32, 32, 32. Thank you very much. There it is. All right, it's y equals 0, just like it says right there. That way I know both answers are correct. In our next example, another dead giveaway. You got your parentheses already squared, so 5 plus the square root of x is going to be my u. So we'll change it out to u squared plus 6u plus 2 equals 0. Wait a minute, that doesn't factor. Okay, because it's a 1u squared, I'm going to complete the square. So subtract over the 2, put in your plus blanks. Remember, completing a square, we're going to take half of a positive 6 is a positive 3 squared, which becomes 9. And the two terms that are squared go into your binomial set of parentheses squared. Negative 2 plus 9 is 7. We take the square root of both sides. We get u plus 3 equals plus or minus square root of 7. Subtract over the 3 and sneak it in front of that plus or minus. All right, okay. Now, we got to solve for x. So bring back the 5 plus the square root of x for u. And okay, we got to get this square root of x by itself, so we're going to subtract the 5 over to make this a negative 8 plus or minus the square root. Wait a minute, hold the phone, time out. Square roots have to be equal to positive numbers. That's a pretty good sized negative 8 there. And the square root of 7, that's like less than 3. So negative 8 plus 3 even is negative 5. And negative 8 minus 3 is another negative. I get nothing but negatives here, and square roots can't be equal to negatives. So, ladies and gentlemen, that's a no solution. So be careful. Always be on the lookout when you deal with even roots. Even roots set equal to a negative, you're going to cancel that possibility out. And in this case, both answers, negative 8 plus the square root of 7 would be negative. And negative 8 minus the square root of 7 is also negative. So there is no solution here whatsoever. Now, if you go back to the previous problem and think, well, I'm going to graph that whole left side that's equal to 0. You graph it, your entire graph is going to be above the x-axis. It will never cross the x-axis. Therefore, no solutions. All right, next. Wait. Both sets of parentheses are exactly the same. All right, put your u's in for that trinomial. There you go. U squared minus 13u plus 30 equals 0. All right, let's think here. Two numbers that multiply to be 30 add up to be a negative 13. If it's going to add up to be 13, both numbers have to be less than 13. So 15 and 2 won't work. Oh, 10 and 3. 10 and 3 add up to be 13. They're just both going to have to be minus signs. All right, so we'll solve this for u. Add over the 3, add over the 10. All right, solve for x. We got to bring down that ugly trinomial, x squared minus 4x minus 2. Holy cow, I hope these are going to be factorable. Subtract over the 3, that'll be minus 5. Subtract over the 10, that'll be minus 12. All right, let's think. 5 and 1. 5 minus 1 is 4, so the 5 has to be negative and the 1 will be the positive. Solve for that. X equals 5, x equals negative 1. All right, over here are two numbers that multiply to be 12, and they got to subtract to be 4. One's got to be bigger than 4. Oh, 6 and 2. 6 and 2, and 6 will have to be the minus sign because the bigger number has to carry the sign. So x minus 6 equals 0, x plus 2 equals 0. Add over the 6, subtract over the 2. There's all my answers. Okay, what do we got here? X to the 1/3 plus 2x to the 1. Wait a minute. We had 2/5 and 1/5 before. I should have the same denominators. Wait a minute. Well, I see it. They're being sneaky here. 1/3 is the same as 2/6. So that makes my x to the 1/6 my u. Okay, nice try. We're going to subtract over the 3, make sure it's set equal to 0. All right, my u squared, like I said, that's 2/6. That's my 1/3. Yeah, that's what they're doing. So we're going to go u squared plus 2u minus 3 equals 0. All right, next, let's see, factor. How about a plus 3 minus 1? There they are. And we're going to get u equals negative 3, u equals 1. Okay, that's good. Then we got to bring in the x to the 1/6 back in for u, which is like saying, okay, the denominator is the root, so the 6 root, wait a minute, even root, negative value, no solution. That's done. Here's positive, we're okay. Well, 1 to the 6th power is still 1, so that's our only answer for that particular problem. All right, so that'll wrap up 9.4.